Hi guys, this is Vineet, and in this video we will discuss about how you can create filter indexes inside SQL Server. Before we proceed ahead, I would request you guys to please subscribe to my channel. As subscribing gives us huge motivation to create new videos for you and for other SQL professionals. Right now I have somewhere around 323 subscribers with 132 videos on my channel, and I want the subscriber count to soon reach 500 subscribers, and I will be posting more videos. I post videos every Tuesday, Thursdays and Saturdays, and right now if you see towards the right, out of 100 subscriber, only 4% of those subscribers are subscribing to our channel. In order to subscribe, there's a subscribe button below this video. Arrow is indicating the subscribe button nearby area just below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. On the right you see an animation where it is showing how you can subscribe and get notified for all my notifications. And also there are some points to remember before watching this video. Please watch this video till the end to gain better clarity of the concept, and if possible for you, please watch this video twice. Perform any exercises in your lab environment or test environment only. Do not use any production environments. And we would like to know your thoughts regarding our videos, so please share your comments. And apart from that, if you want PDF copy of the notes that we are discussing in this video, there are two methods. First method is you can pay a nominal fee at the link given below. I will include this link in the description. So you may download from this link by paying a nominal fee. And second method is you can subscribe to my channel and send the proof of your subscription to my email address, which is vermavine@gmail.com, and we need a screenshot showing a proof of your subscription along with my channel name. That is required, and you can also send me the name of the video for which you want the PDF notes. For this video, the name will be found from below just below this video. It will indicate the complete title of this video. I need the title to send you the PDF notes. So once I get your subscription proof screenshot, I will send you the PDF copy of the notes on my on your email address. And apart from that, I have created few playlists to watch. Two of the main playlists are database design videos playlist, and another one is the business continuity playlist. And business continuity playlist has around 45 videos, and database design also has around 30 videos. And apart from that, I have a channel page link as well, which is youtube.com/@SQLTalks by Vineet. You can find all these links in the description area of this video. And if you have any questions related to SQL Server, you may ask them so by paying a nominal fee of INR 500 for a single question at the link given below. This link is also included in the description. Also, if you need help with writing your profile while preparing your resume, I am available for consultation with an hourly charge of INR 1000, and you may avail this service by going to the link below. This link is also included in the description area. So let's proceed ahead. Let's go back to the topic, which is how to create filter indexes in SQL Server. Let's quickly go to notes. Let me select the pen pointer from the draw section. Okay. So today's topic is how you can create filter indexes inside SQL Server. And this video describes basically how to create filter indexes using SQL Server Management Studio, and we will also show you how you can create the indexes using Transact-SQL statement. Now, what is a filter index? A filtered index is an optimized disk-based row-stored non-clustered index. So it's basically a non-clustered index, which is a row-store base, contains a subset of rows from a table. It's built on that subset. It's a non-clustered index, and it's especially suited to cover queries that select from a well-defined subset of data. So basically this index is created on a subset of data, not on the complete table, but only on the subset of data. So that is a filter index. And that filter defined on the where condition in the query. So we use that filter for the filter index. We will discuss soon. So yeah, it's a non-cluster index that is especially suited to cover queries that select from a well-defined subset of data. Basically, this index uses a filter predicate to index a portion of rows in the table. So it does not index all the rows in the table, but it only indexes the portion of rows. Index a portion of rows in the table and not the complete table. A well-designed filter index can improve query performance. So why we create filter indexes? Basically to improve the query performance and basically to reduce index maintenance. So filter indexes have low index maintenance compared to the indexes that are created on the whole table. So we create filter indexes to reduce the index maintenance and to increase the query performance as well. And we use them to reduce the index maintenance and storage costs. So filter index requires less storage compared to the full table indexes, so that saves us on storage. So prevents any additional storage costs compared with the full table indexes. So full table indexes have more storage costs associated with them. Now let's discuss some of the advantages of filter indexes. So filter indexes can provide the following advantages over a full table indexes. Now it improves the query performance and plan quality. That is one of the benefits. It improves the query performance and the execution plan quality. We will discuss, we will create videos on execution plan soon, so keep a watch on my channel. Please subscribe, hit on the bell icon and select all notifications to get notifications regarding the execution plans that I will create soon in the coming days. Those will be out. And a well-defined or a well-designed filter index improves the query performance and the execution plan quality. So a well-designed filter index, basically what benefit does it provide? First of all, it improves the query performance, and second is that it provides a good execution plan. It improves the execution plan quality as well. Because why it improves the execution plan quality? Because it is smaller than a full table non-cluster index. So filter indexes are smaller than the full table non-cluster index, and as they are smaller, they improves the query performance and also improves upon the execution plan quality. And it also has filtered statistics as well, and they filter statistics, and basically the filter index statistics or filtered statistics are more accurate than the full table statistics. So filter statistics are more accurate than the full table statistics because they cover only the rows in the filter index. So their statistics are more accurate than the full table indexes, as they cover only the portion of rows in a particular table. Now, reduce index maintenance costs. That's the another benefit of filter indexes. It reduces our index maintenance costs. Now, an index is maintained only when the data manipulation language or daemon statements affect the data in the index. So the index maintenance is only required in the case of filter indexes when we are using any data manipulation language statement or the daemon statement to affect only the rows that are the part of index. If updates are made to any other rows outside of the index, then index maintenance is not required. So only if the data inside the index is modified, then the index maintenance is required. Only this is the criteria. If the data in the index is modified, then only the index maintenance is required. Now, a filter index reduces index maintenance costs compared with the full table non-cluster indexes because they are smaller and is only maintained when the data in the index is changed. So that is what we are discussing in this section. So the index is only maintained when the data in the index gets affected, otherwise not. And whereas if you compare it with the full table index, any rows if we affect in the table, index maintenance is required. So a filter index reduces the index maintenance cost compared with the full table non-cluster indexes because they are smaller and they are only maintained when the data in the index is changed. Now it is possible to have a large number of filter indexes, so we can create many filter indexes on a particular table, especially when they contain data that is changed infrequently. So we can create many filter indexes on the table, especially in the situations where we feel that that particular set of data is changed infrequently or changes are not made to the data very frequently. We can create many filter indexes on a particular table. Similarly, if a filter index contains only the frequently modified data, so if our data is a frequently modified data and if it's a part of a filter index, the small size of the index reduces the cost of updating the statistics. Now first of all, we were talking about that we should create filter indexes, especially when we have a set of rows that we don't modify frequently. But even in the case where we have rows that modify frequently and they are part of, even if they are part of filter index, cost of updating the statistics, index statistics, is very low due to the small size of the index. So that is also the additional benefit compared to a full table index. Now, it also reduces the index storage costs. As the filter indexes are small, so there is less storage cost to keep those indexes. Creating a filter index can reduce disk storage cost for non-cluster indexes when a full table index is not necessary. So in the cases where the full table index is not necessary, we can create filter indexes on the table, and those indexes consume less storage space, so our index storage cost is reduced. You can replace a full table non-cluster index. You can also do this thing. We can replace a full table non-cluster index with multiple filtered indexes without significantly increasing the storage requirements. So instead of a full table non-cluster index, we can also create the multiple filter indexes that will serve the same purpose, and that would also will not significantly increase the storage requirements. Now let's talk about some design considerations for the filter indexes. Now let's talk about some design considerations. So let's consider a column in a table that has only few relevant values for queries. We can create a filter index on that subset of values. The resulting index will be smaller and it costs less to maintain than a full table non-cluster index defined on the same key column. So if a particular column has only few relevant values for queries that we are executing, that column contains only few relevant values for queries, we should consider creating a filter index on that particular column instead of a full table non-cluster index, as it will cost less to maintain and the index will be smaller as well. Now let's consider an example. Consider a filter index in the following data scenarios. In each case, the where clause of the query should be a subset of a. So we are discussing a scenario. In each case, the where clause of the query should be a subset of a where clause of the filter index. So here are some examples of the query where we use the where clause in the query as a where clause of the filter index to benefit from the filter index. Now when the values in a column are mostly null, and the query selects only from the null values. And this is one of the scenario where we have mostly null values in a particular column, and the query, if we have a query that only selects from a null values, we can create a filter index for the null data rows. This is first scenario. Second scenario is when the rows in a table are marked as processed by a recurring workflow. So workflow is basically a script, and if it marks certain rows in table as processed, maybe we are using a particular column to track that processed data, maybe a disposition column. So if a working workflow is marking that column as processed for the rows that are processed or queue process, over time most rows in the table will be marked as processed, and we can create a filter index on the rows that aren't yet processed, and this would benefit the recurring query that looks for the rows that aren't yet processed. So workflow basically looks for the rows that are not processed, and after processing them, it marks those rows as processed. So we can, in the filter index, we can include those rows that aren't yet processed, and that would benefit the recurring query that looks for the rows that aren't yet processed. This is the second scenario. Now the third scenario can be when a table has heterogeneous data rows. You can create a filter index on one or more categories of data. This can improve the performance of queries on the data rows by narrowing the focus of a query to a specific area of the table. Again, the resultant index will be smaller and cost less to maintain than a full table non-clustered index. So third scenario can be a heterogeneous data row situation where we have several categories of data, and we can create a filtered index on a certain categories of data. Multiple filter indexes can be created as well, and creating these filter indexes will benefit us in terms that they are smaller and they are less costly to maintain than a full table non-clustered index. Now there are some limitations and restrictions on the filter indexes. Now we cannot create a filter index on a view. So on views we cannot create a filter index, but yeah, we can definitely create a non-clustered index on a view. However, the query optimizer can benefit from the filter index defined on the table that is referenced by the view. So instead of creating a filter index on the view, we can also create a filter index on the source table that the view is referencing, and the optimizer can reap benefits from that as well. So however, the query optimizer can benefit from a filter index that it defined on the source table that is referenced by the view. So there are still benefits of defining the filter indexes on the source table that the view is referencing. The query optimizer considers a filter index. So in those situations where the filter indexes are defined on the source table, the query optimizer considers that those filter indexes for a query that seeks data from a view or selects data from a view if the query result will be correct. So that filter index can be used even if it's not created on the view but instead created on the source table. The query optimizer will automatically consider that index, that particular filter index for a query that selects from a view if the query results are correct. And you cannot, another limitation is you cannot create a filter index on a table where the column accessed in the filter expression is of a CLR data type. So a particular column should not be of a CLR data type if you want to use it in a filter index. If the particular column contains a CLR type data, then a filter index cannot be created on such columns in a table. Now, filter indexes have a following advantages over the index views. Index views are basically views which have non-clustered index created on them. Now, what are those advantages of filter indexes in contrast to the index views? Basically, it reduce the index maintenance cost. So filter indexes are less costly to maintain. Now, for example, the query processor uses a fewer CPU resources to update a filter index than the index view. So less CPU resources are required to update the or fewer CPU resources are required to update the filter index rather than a index view. Now it also improves the plan quality, which is the execution plan quality. For example, during query compilation, the query optimizer considers using the filter indexes in more situations than the equivalent index view. So even if we have both index view created on a particular view, if we have an index created on a particular view, and if we have a filter index created on the source table which the view is referencing, then the query optimizer will still consider the using the filter index instead of equivalent indexes created on the view. Now another advantage is online index rebuilds. You can rebuild filter indexes. You can rebuild filter indexes while they are available for queries. So we can online rebuild these indexes. And what's the benefit of online index rebuilding is that those indexes are still available for queries. Online index rebuilds aren't supported for index views. So index views, if we are rebuilding an index of a particular view, online index build is not allowed. Now another benefit is the non-unique indexes. That is the benefit. Filter indexes can be non-unique, whereas index views must be unique. So index created on views must contain the unique values, whereas the filter indexes can be non-unique and can contain non-unique values as well. So that is one of the other benefits of using the filter indexes. Index can be used, but yeah, we can still have non-unique values in that particular index or a column. Now we were discussing about the limitations. We discussed about some of the benefits here, but yeah, let's come back to limitations. So filter indexes are defined on one table and only support simple comparison operators. So filter indexes are defined on one table and only support simple comparison operators. If you need filter expression that references multiple tables or has complex logic, so let's clear out this point. So we cannot include columns from multiple tables while creating the filter indexes. That is what it is saying. So filter index can be defined on the columns from a single table only and not from multiple tables. And it also only supports the simple comparison operators and not the complex ones. And if there is a requirement to create a filter expression that references the multiple tables, that is not available. So that is not permitted. Basically, we cannot create filter indexes on the columns from multiple tables in a filtered expression. Or if the filter expression has a complex logic, then yeah, those complex logic comparison operators cannot be included in that filter index, and you should create a view at that time. If there is a references to columns from multiple tables, we should create a view. We should create a non-cluster index on the view, complete view. Filter indexes do not support the like operators as well, so that is another limitation of filter indexes. Now a column in the filter index expression doesn't need to be a key. So it cannot be a, there's no requirement that a column included in the filter index expression where it should be a key column of a table. So it doesn't need to be a key or included column in the filter index definition if the filter index expression is equivalent to the query predicate and the query doesn't return the column in the filter index expression. So it all depends upon the query we are using. So whatever columns are used by query in the where clause, those all columns can be included in the filter index, and there is no certain requirement that the particular column should be a key column or something like that. Now a column in the filter index expression should be a key or included column in the filter index definition if the query predicate uses the column in the comparison, or if that column is the is in the query result set. So we only use key columns in the source table as a part of filter index if those columns are used inside the query where clause basically, or if those columns we are outputting in a query result set, then yeah, we can create a filter index on the key column. Otherwise, if our query is not using that particular key column, those particular column or that particular column cannot be a part of filter index or should not be a part of filter index. Let's come to next point. The clustered index key. Now another statement. The cluster index key of our table doesn't need to be a key or included column in the cluster index definition. The clustered index key is automatically included in the all non-clustered indexes, including the filter indexes. So here we are talking about the cluster index keys. So the cluster index keys of a table doesn't need to be a key or included column in the cluster index definition. Basically the clustered, so let me check this point, give me a second guys. So some correction is required here, let me include that. So that is basically the filtered index and not the cluster index. So let me reread this statement. So let's go back to the drawing mode. Okay, so the cluster key index key of the table doesn't need to be a key or included column in the filter index definition. So any column which has a cluster index key, it should not be a included column in the filter index definition. I mean there's no need basically to include the cluster key column or cluster index key of a table. Doesn't need to be key or included column in the filter index definition. The cluster index key is automatically included in all the non-cluster indexes. So all non-cluster indexes basically references the clustered keys if a cluster index is defined on a particular table. And this is true for filter indexes as well, as they are also non-cluster indexes. So they contain references to the cluster index key automatically, and we specifically or deliberately do not have to include those clustered key columns as a part of filter index definition. Now if the comparison operator is specified in the filter index expression, so if we are using a comparison operator in a filter index definition, filter index expression basically, if you are using the comparison operator of the filter index results in an implicit or explicit data conversion, an error will occur if the conversion occurs on the left hand side of the comparison operator. So let me clear this out. So if we are using comparison operator in a filter index, and that particular comparison operator statement, we have a left hand side and we have a right hand side to the comparison operator. So if a conversion is occurring towards the left hand side of a comparison operator, we will get an error. The solution may be to write the filter index expression with the data conversion operator cast or convert on the right hand side of the comparison operator. So we should always write any conversion statements on the right hand side of the comparison operator if they are part of the filter indexes. Now filters cannot be applied to a primary key. So filters cannot be applied to a primary key or unique constant. So if we have a column which has a primary key defined on it or a unique constant defined on it, so filters cannot be applied to a primary key, but can be applied to the indexes with the unique property. So here we are talking about filter index. So in a filter index we cannot apply a filter on a primary key column or any of the unique constants created on a particular column. That column cannot be used in a filter section of the filter indexes, though we can apply filters to the indexes with the unique property. Let me reiterate. So filters cannot be applied to a primary key or unique constants. If those filters are the part of the filter index, it cannot be applied to a primary key column or unique constant. But we can use filters if they are applied to column with the unique property or indexes with the unique property. Now we cannot create a filter index on a computed column as well. So filter index cannot be created on any of the computed columns as well. Now let me cover a demo here where we'll create a filter index. Let me show you how you can create a filter index using the SSMS. Then we will cover off the Transact-SQL demo. Let's go to SQL Server. I've invoked the instance, so it should be up within a minute. So let's check it out. Waiting for SQL Server to open. It's opening up. Okay, guys, I'm authenticated to the SQL Server, connected to the instance. Now inside the Object Explorer, which is coming on the left hand side, you need to click a plus sign to expand the databases section. Okay guys, we have expanded the databases section. Then we need to expand the tables folder. So the filter index where we want to create is we need to expand the table. For let's example say sample DB. It has some tables, employees and students. Okay, and they may have some indexes created on it. So both of them has two indexes. Let's remove these indexes quickly. So the way, yeah, we can delete it. So deleting this index. This index is removed. Let me remove this index as well. For the table, I am also removing the indexes. Waiting for the operation to complete. Should complete in few seconds. Okay, last index is remaining. Let me delete that as well quickly. So now we don't have any indexes defined on the employees and student table under the database sample DB. So we have expanded the tables column, tables folder. So in order to create a table index, you need to right click on the indexes folder. So for example, if we want to create an index on the employees table, it has two column, employee name and employee ID. Right, in order to create an index, what you need to do, you need to right click on the indexes folder, point to a new index and then select the non-cluster indexes. This is just I'm showing you the way. I'm not creating an actual index here. We will show you how you can create actual indexes using the Transact-SQL, but here I'm showing you the procedure. So the procedure is to right click on the indexes folder, go to new index and go to non-cluster indexes option. Now after going to the non-cluster indexes option, we have selected a new index option. So after that, a new index dialog box open and we are on the general page of that index. We need to enter the name of the index. So name of the index can be entered here. We can modify it here. So for example, we are creating a cluster non-cluster index on the employee name table, so maybe I can mention the employee name column. So the non-cluster index can be defined in this way. So here we have defined the name of the new index. Now there is an index key column section. We need to click on add. So it will open up a dialog box to select columns. So in the select columns from table name dialog box, select the checkbox or the checkboxes of a table or columns to be added to the index. So here we are using the employee name as the column for this non-cluster index, and we need to click on OK to create a filter index. And filters can be defined here. So if we want to create make it a filter index, so filter can be specified here. So here we need to add a script here. We can directly use an query editor window, and we can create a script here, or in the filter expression we can directly mention the where clause. So let me select some columns from this table. Select top 100 rows. So it is giving me three rows, Ram, Sohan and Mohan, with the employee ID 1, 2, 3. So now in that particular dialog box where I have selected the script new query editor window, it has given me a new query editor window. So that is basically to script out the index creation operation. I don't want to script it out, but yeah, here we can define the filter expression. Maybe I can say where employee name equal to Sohan, maybe. So let me apply a filter expression. So I'm doing a select star from employee name. So I'm selecting employee name, employee ID from this table sample db.employees, and here I'm specifying the where clause where I'm saying employee name equals Sohan. So yeah, that filter condition can be defined there as well. So we can put it here. Let's create OK. So it is failing, so I think I just need to include the where clause here, where employee name equals Sohan. That should be correct. So let's click OK. So we got some errors. So it is saying that we have incorrect syntax near the keyword where. But I think my syntax is right, so let me execute this statement. Syntax seems to be right, so why that is happening? Let me check and get back to you. So guys, I've modified that where clause. So let me show you the properties of this index which is just created employee name. So in the filtered section, instead of using the where option, I've just specified employee name equal to Sohan. I'm not using the where statement here. So this is the filtered expression. The index will be created on the subset of rows which contains the employee name Sohan. So there is only one row. The index will be created on that particular one row. So yeah, this index is created, and yeah, we are fine here. Index is created. It's a non-unique, non-clustered filtered index. Filter is also specified here because we have specified the filter criteria where employee name equal to Sohan. So this is how you create out the filter indexes via the SQL Server Management Studio. Now let me take you through an example. Let me remove this index as well. So I'm deleting that off. So this index is deleted. Now let me take you through a demo where you will create a filter index using the Transact-SQL statement, and here we will be using the and VentureWorks 2022 database. So let me create a new query. We will be creating a filter index on particular table. Let me show you that table where I will be creating the filter index. So the table will be production dot bills of materials. Here I will be creating that index. So I've created a new query. It is referencing AdventureWorks 2022 database. So along with me, you can type this code out. So first of all, we can check if that particular index already exists. But here I'm not using this statement. Let me first create the index. So in order to create an index, you can create. Let me see what indexes it has. So if you go to indexes, okay, so let me create a non-clustered index here. So non-clustered, create non-clustered index, and we need to specify the name of the index here. So I'm specifying as fi bill of whatever name you like. You can specify it over here, maybe some logical name that gives you some sense. So fi bill of materials with end date, I'm selecting. So basically I'm creating an index fi bill of materials with end date. This is the index name, and after that you need to specify the column on which you want to create the index. So you need to specify the table, so that is under the production schema. So production dot bill of materials, on which column we have to create the index. Now let's see the columns here. So I will be creating these this particular index on column. Let me select the column. So I will be using the component ID, which is a foreign key from another table, and I will be using start date. So I'm using these two columns. So I've selected component ID and start date as the index columns, and here I'm specifying the filter criteria for the filter index. As this is a filter index, I'm specifying the filter criteria, and in this filter criteria I'm using this column end date, and I'm specifying where end date is not null. So I'm selecting all those bills. The query is selecting all those bills where end date is not null, and this index can be useful in those situations. So I'm creating an index. I've created them on the production. I created the index on the component ID in start date column, and for filter criteria I've selected where end date is not null. Now let's create this index quickly. Now this index is created. If we refresh the indexes section, you will see this index. This is the one which we have created just now. Now the filter index, whatever fi bill of materials with end date. Now for which query this index will be valid or will be selected if we use that particular query. So what should be the query that will reference this index? So as this index is created on the component ID and start date column, let me write an associated query. So let's see, I'm selecting some columns. Let me do star here. Let's star from production dot bill of material. Table should be same, so here I'm mentioning the table name. I'm selecting few columns from this table. So one of them is the production assembly ID. Another one is I'm selecting both of these columns as well, so I can take it from here. So 3 columns are being selected from the production.bills of materials table, and where we can specify the same filter criteria I'm using for the filter index, where end date is not null. So end date is not null. Alright, and we can specify any additional conditions as well in the AND criteria maybe, and where end date is not null, and we can say component ID equal to 5 and start date maybe greater than 2008. So this is the query I have specified where I'm selecting product assembly ID, component ID, and start date from production.bill of materials table, and we have specified the criteria whatever we are using in the filter. This query is also using that criteria where end date is not null. In addition to that, it is using some additional criteria. So when this query will be executed, the query optimizer will automatically use this particular index. That can be checked through execution plans, but yeah, I will cover execution plans later. For now, if you need an execution plan for a particular query, you can select that query out, and there's a button for display estimated execution plan. It will show you the estimated execution plan. So if we look at this index plan, it is using the non-clustered index seek. So what is the index that is being used? So it is using a non-clustered index seek, and it is using this particular index FI bill of materials with end date. So you see object section on the right hand side, it gives you the name of the index that it will be seeking. So this query is, this index will be useful for the queries like this, whichever I have mentioned right now. So if we execute this query, that query will use this particular index, and that index is quite less costly to maintain. It is, as it is not created on the whole table, but instead of a criteria where we have selected a subset of rows where end date is not null. So this index is less costly to maintain and provides a good query execution plan as well. So this is how you can create the indexes, filter indexes on the basis of query criteria. After first you write the queries. Here we have done the opposite. First we have created the index, and then we have written the query. But ideally we have a query first, and on the basis of that query we create index, right? So we should read the query criteria, whatever queries are we using, and we can then define our filter criteria for our filter indexes. So it's a non-cluster index, index name, the table name, and the columns we are using. And filter criteria can be taken from this query as well, whatever filter criteria we want to use for index. So we have used end date is not null. So this is how you create the filter indexes. So guys, let me go back to the video. Let me go back to the notes. So I hope you like this video. In video we have shown you how you can create the filter indexes, and we have discussed some of the advantages of filter indexes, which is improved query performance and plan quality, reduce index maintenance costs, reduce index storage costs, and we have discussed about some design considerations while creating the filtered non-cluster indexes. We have talked about some of the limitations of filter indexes and the restrictions applicable. Towards the end, we have shown you two demos. First is via the SSMS studio, where we have shown you how you can graphically create the filtered non-cluster indexes, and second demo we have shown you how you can use the Transact-SQL statements to create a filter index, where we have used the filtered criteria here, and we have shown you the query as well, which is using this filter index, and via the show estimated execution plan. So there will be more videos coming on how you can read the execution plans under the performance tuning section. So keep an eye for it, and do subscribe to my channel. There's a subscribe button below. Click on that subscribe button. When you click on the subscribe button, you will get a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my future videos. Guys, please share this video with your friends in case you feel this video is useful for them, and also please ask them to subscribe to my channel. I need more and more subscribers as I am on the initial stages of my YouTube channel building. and do comments on our videos, as we really like your comments. Thank you for your time on this video today, and you have a nice day ahead.